4.3, dividing polynomials. In this part, we're going to be looking at polynomial long division. To remind you on how to divide long division, let's look at dividing 106 by 5. You take 5 into 106, and the question is, what number times 5 gives you 10? 2 does. Subtract down and bring down the 6. What number times 5 goes into 6? 1. You get 5 with 1 as a remainder. So the answer is the quotient, 21, with a remainder of 1 over the divisor. So a couple of these terms, divisor is the 5, the dividend is the 106, quotient is 21, and the remainder is equal to that 1. Notice that this form, 21 plus 1/5, can look like this or that form. And I wrote it as the plus because in the next slide, you can see that when you take a polynomial dividing by a divisor, you get a quotient plus the remainder over the divisor, just like you did in that simple division problem with numbers. But you can do the same thing with polynomials. I wrote this out beforehand because there's quite a few numbers, but I can talk through it. Now, a couple things to notice. This is the divisor. It comes here. And very important, if you're missing any terms at all, you have to fill them in with zeros. So, for example, I'm looking at this right here, and this is x to the 4th plus 2x squared. There's no cubic term, so I'm going to put 0x cubed in as a placeholder to keep things nice and orderly. That's a real popular test question, which leaves out a term, and you have to put in a placeholder. Also remember that if you have a 0, if you don't have a constant term here, you're going to want to put a 0 term in here as well. So the very first one, it's x minus 1 goes into this polynomial, and the question is, how many times does x go into x cubed? It goes in their x squared terms. I'm going to put it right above the x squared term. So I multiply x squared times x minus 1 and get this. And then I'm going to put in big parentheses, really important, big parentheses here to remind me that I have to subtract all the way through. These will always cancel out if done correctly. This becomes plus, and you get a 0. In this case, you're going to bring down a minus 2x, and you also bring down an 8 because it will line up correctly if you do that. So I'm going to put minus 2, and again, multiply negative 2 times x minus 2, and you get this, and again, big parentheses, and subtracting down gives you 6. So the way to write this is you have the quotient plus the remainder over the divisor. Looking at the other problem, again, there's a missing term here, so I'm going to fill that in right here. I'm going to look and see how many times is x squared going to x to the 4th, x squared amount of times. I put that above the x squared. I then distribute that x squared all the way through. I get this, big parentheses, subtract going down. If this doesn't equal 0, just bring down the next term and then write what x squared times what gives you x cubed, and that answer is x. So distribute, subtract, and bring down the next term. Again, big parentheses, subtract, big parentheses, subtract. I see so many mistakes, and that's why I'm trying to reinforce this big parenthesis idea. And then you get 3 as a remainder. Once you have 3 as a remainder, you write it as the quotient, remainder over the divisor.